Good evening, everyone. I'm Ritesh Jain, working as a research economist in CSTEP, and my research areas are solar power manufacturing and energy storage systems. So, dear friends, I'll be having the question and answer session in the last. And so I would like to begin with the presentation right here.
The leader has muted your line.
As the title suggests, the presentation deals with the overview of solar manufacturing in India in the three contexts. Particularly, I'll be dealing from the perspective of the solar PV technology types, comparison of India's production and installed capacity with the world, and the corresponding market share of PV technologies, and thirdly, the protectionism measures used to protect the domestic solar manufacturing industry. So here is the scheme of the presentation. Beginning with the distinguishing features of the crystalline PV and the thin film PV, I will be taking an overview of the solar policy in India and what are the components that goes into the manufacturing of the solar PV module and the total solar plant installations, what is the status, and the next slides will deal with a quick comparison of the India's production and installed capacity with the world. And finally, we will be discussing the challenges faced by the Indian solar manufacturers and the road ahead. Well, the solar photovoltaic technology can be categorized into two, crystalline PV and the thin film PV. Crystalline photovoltaics can be further categorized into monocrystalline and the multicrystalline, and the thin film can be categorized into amorphous silicon, cadmium telluride, copper, indium gallium selenide. The two PV technologies differ primarily in three aspects. First is the energy efficiency. As you see, the efficiencies of the crystalline PV are relatively higher than the efficiencies of the thin film PV. Secondly, the manufacturing processes involved in the crystalline PV technology are far more complex and disaggregated than the manufacturing process involved in the thin film PV technology. In thin film PV technology, deposition of the various layers are carried out on the substrate. A substrate can be either stainless steel, or it can be a glass, or it can be any other flexible substrate. While in crystalline PV, silicon wafers are used to produce a cell. And another distinguishing feature of two technologies is the supply chain. The supply chain of crystalline PV is highly disaggregated and complex, while the supply chain of the thin film PV is more aggregated and more vertically integrated. Talking about the basic differences, I would like to focus on what the thin film PV has few advantages of the crystalline over crystalline PV. The advantages relate to the its low cost. One of the main reasons why the thin film PV became a major area of focus in R&D in the beginning of the 21st century was the low cost and the supply side constraints faced by the crystalline PV in terms of polysilicon supply worldwide. So the advantages of thin films are the lower cost, and the performance of the thin films is far better when compared to crystalline PV in the diffused radiations, and the temperature coefficient of thin films is relatively lower than the crystalline PV. The temperature coefficient means with the increase in the temperature, the decline in generation will be far lower than the decline in generation in case of crystalline PV. So the temperature coefficient of thin films is plus minus 0.25 degrees centigrade, while in case of crystalline PV, it is more than 1 degree centigrade. Now, talking about the advantages, thin film have two Disadvantages, because as we have already discussed, the efficiencies of thin films are far lower, and this lower efficiency leads to the large area requirement for the same watt capacity, for the same installed capacity. For example, if we talk of installing a 1 kilowatt solar PV system, then on an average, the area required for the thin films 1 kilowatt will be 1.6 times a thumb rule than the area required by the crystalline PV. In the coming slides, we will be discussing the production capacity and the installed capacity in India and across the world. Now, taking a brief look at the solar policy in India, JNNSM, Jawaharlal Nehru National Solar Mission, was launched in year 2010, and besides having a objective of installing 22 gigawatt of solar power by 2022, its another key objective is to make India a global manufacturing hub with a manufacturing capacity of 4 to 5 gigawatt by 2022. The mechanism adopted to promote domestic solar manufacturing was the domestic content requirement. Domestic content requirement mandates the project developers to source a fixed quantity of solar cells or modules or the balance of systems from the domestic manufacturers. This provides a demand to the domestic manufacturers. So in the phase 1 of the JNNSM, batch 1, the DCR was imposed on the crystalline PV modules. In the phase 1 of the batch 2, it was extended to the crystalline PV cells as well as modules. The reason why government went for the imposition of DCR only on crystalline PV and not on thin films, because there were no substantial manufacturing capacity for the thin films in India, except for a sole manufacturer, Motherwear, which has the 50 megawatt capacity. So government went with the DCR only on the crystalline PV technology. In the phase 2, after almost an year's delay, the government have come up with the DCR norms in phase 2 batch 1. It plans to adopt a DCR for 375 megawatt out of 750 megawatt. The difference between, I'll be discussing in the detail in the coming slides, that this particular policy has led to a scenario of which is very different to the world scenario in terms of the technology share in the market. In 2010, National Tariff Policy 2006 was also amended to have the 3% solar penetration in the grid by 2022 with an increment of 0.25% every year from 2012-13. Now, here are the overview of the solar PV components. On the left-hand side, there is a list of the components which goes into the manufacturing of a PV module. On the right-hand side, there is a balance of system components which are used to integrate the solar power plant with the grid. Now, without going deep into the component-wise specification, a majority of the components are imported in India. And the components which are not imported, domestically manufactured, a majority of the raw material is imported. Like ingot, we don't have the manufacturing capacity for the ingot and wafer. Cell, we have almost 1 gigawatt of manufacturing capacity. Gases required are of like very high purity gases of the 7N level, that is 0.0007 times 999%. So here I would focus some light on the inverted duty structure versus duty-free finished good imports. Why I'm focusing on inverted duty structure? Because the domestic manufacturers, let me explain what is inverted duty structure. Inverted duty structure, under inverted duty structure, the import duty on the raw materials is far more than the import duty on the finished goods. So the inverted duty structure acts against the domestic manufacturer and in favor of the imports of the finished module. So the domestic manufacturers which import raw material for the manufacturing of the finished module import it at a higher duty, while the project developers which import the finished modules or finished component, they get it at almost zero duty. So this is one of the reasons why the cost of domestic solar cell and modules is higher when compared to the imported modules. Now I will be having a quick comparison of the manufacturing capacity and the installed capacity technology-wise in the world and in India. As you see on the left-hand side, the current manufacturing capacity across the world is 70 gigawatt. And in the graph, the bar graph, you see in the year 2012, 29% of manufacturing capacity is for the thin films, and the rest 71% is allotted to the PV. And if you see from 2008 to 2012, the production capacity for thin films has increased. On the right hand side, the installed capacity, current installed capacity for the world is around 98 gigawatt. And as per the GTM research, in the year 2013, overall installations will be around 30 gigawatt. And if you see the deficit along the both sides, on the one side there is 70 gigawatt of manufacturing capacity. On the right hand side, the demand is 30 gigawatt. So the deficit is, there is a deficit of 40 gigawatt. So there is a huge quantity, huge production lines are being shut down due to absence of demand. On the right hand side, if you see in the pie graph, in the year 2011, 11% of the solar PV were thin films, while 89% was a crystalline silicon. And this 11% came down from 18% in 2009. As I mentioned in my previous slides, the focus on the thin films increased in the beginning of the 21st century for the supply constraints of the polysilicon. So the share increased from 2% to almost 18% in 2009, but due to the overproduction of the polysilicon in the later half of the first decade led to decline in the prices of the polysilicon, and the thin film share consequently declined from 2009 and it came down to 11% in 2011. If we compare the same picture for India, then we'll see, let us see in the next slide. On the left hand side, if you see the manufacturing capacity for India, for cells in India is 1 gigawatt and for modules is 2 gigawatt. The bar graph shows how the manufacturing capacity is increased from 2007 to 2013. But the point to be noted here is that although the manufacturing capacity is 1 gigawatt to 2 gigawatt, but as per the contemporary scenario, 80% of the manufacturing capacity is lying idle, lying unused because of the absence of demand. Most of the projects that are developed in India are using imported cells and modules. On the right hand side, if you see the installed capacity as per July 2013 is 1.8 gigawatt, and the technology share is 44% for thin films and 56% for crystalline silicon. If you compare it with the world market share, which is 11% and 89%, India is 44% and 56%, which is very, very different. I would like to discuss the reason, what is the basic logic, why the scenario turned up like this. So, as I discussed behind it, first is the thin films performance is better than crystalline performance in the tropical countries. Temperature variation is high. So in India, the performance of thin films is good, but the main reason for the bias towards the thin film is the Indian solar policy of domestic content requirement. Domestic content requirement was imposed only on the crystalline PBA, not on thin film PBA, as India did not have any substantial manufacturing capacity. So the project developers, taking advantage of this flawed policy, preferred the cheap imported thin film modules in India. So a majority of the solar project used imported thin film modules from US, primarily First Solar. So this is the reason why there is this two different scenarios. One is 11%, and while in our country it is 44%. So in phase 2, government has floated the DCR with the two separate widths. So the project developer has to take either opt for DCR or opt for the open category. If he is opting for DCR, there will be separate bids, and if he is opting for open air, there will be separate bids. This is to address the concerns of the developers that the domestic modules cost are higher than the imported modules. So the bids will be higher for the DCR project. Now, this is the last slide. If we look at the challenges faced by the domestic solar manufacturers, then there are many challenges, but I have outlined few. The solar manufacturers and the project developers, as I discussed, are always at the loggerheads. While solar manufacturers wants government to create a demand by domestic content requirement, on the other hand, project developers are against DCR norms because they get the cheap imports from the other countries like China and US and all. So the bid goes down. On the other hand, the country is seeing that less than 60, as I have discussed, less than 30% of the production capacity is being utilized in India. The figure on the right hand side shows that it closed production line in India, shut down. There are many production lines which are shut down, almost 80%. Also, there are more than 70% of the total capacity are using foreign solar cells and modules. Now, one of the reasons why the project developers prefer thin films is the US Exim Bank provided low-cost, long-term financing for the modules imported from US. While in India, the financing rates are very high, and that too they are not long-term. They hover around 13 to 14%, but if you import it from US via US Exim Bank, they hover around 3 to 4%. Now, one of the two major reasons why the cost of solar cells and modules in India is high is the economies of scale. If we see, the highest module manufacturing capacity for a company in India is 280 megawatt, while the same for China, the average for China is 1 gigawatt, that is 1000 megawatt. So the economies of scale, the absence of economies of scale increases the cost. On the other hand, in India, we do not have vertically integrated manufacturing facilities. We have to source equipment from other companies from abroad. Solar clusters and solar parks are missing in India. Now, after these challenges, if we move ahead, then we see that across the world, the trade wars are going on in terms of protectionism measures. On one hand, US has lodged a complaint to WTO against Indian DCR norms because according to the WTO GATS, General Agreement on Trade and Tariffs, the DCR can be applied only if the procurement agency is government. So the investigation is going on, but just to inform you, the same case was lodged against Canada last year, and Canada lost it. Now, anti-dumping measures. like the three Indian companies, Jupiter Solar, Indo Solar, and Repsol, filed a complaint against Japan, European Union, China, Malaysia, Taiwan, and US for the anti-dumping of their solar cells and modules in India at a very, very lower cost, lower than the cost of the production. So on 18th July, a hearing was there, and a prima facie evidence found in proving the dumping of the solar cells and modules from these countries. So the government is now working on the margin of dumping to fix a percentage of anti-dumping duty to every country. Looking at the current scenario where there is a surplus of supply, as we discussed 70 gigawatt, the country should focus on upstream value chain, primarily the balance of components that goes into the manufacturing of a module, like encapsulant, backsheets, frame, junction box, and the balance of systems. Those are inverters and batteries. So overall, the domestic manufacturers are facing majority of challenges vis-a-vis countries like China and USA. In China, a lot of incentives are provided by the government which reduces the cost. While in India, the availability of incentives is not very broad, except for DCR, and there is one more incentive called as Modified Special Incentive Package Scheme. So currently, the domestic manufacturing is facing the brunt due to the glut across the world, PV glut across the world. But it seems like a couple of days ago, phase 2 batch 1 came up, and it's clear that DCR will be there again. So hoping for the best. So this was all my presentation. Now you are open to ask if you have any questions. Thank you.
The leader has unmuted your line.
Here's my mail ID. If you have any queries, please write down the mail to me.